Deep in the heart of an uncharted jungle, covered by centuries of tangled vines and forgotten by time, lies a stone slab so enormous it defies belief, a 500-ton monolith carved with a map that shouldn't exist. What makes this ancient artifact truly mind-bending isn't just its size or age, but the impossible knowledge etched into its surface, a detailed prediction of how the continents would drift apart millennia before modern science even had a name for the phenomenon. This isn't a legend or a hoax, it's a real, tangible mystery that rewrites what we thought we knew about the past. Who could have created such a map? How did they possess knowledge that would take humanity thousands of years to rediscover? And why was this colossal record left hidden, waiting to be found? Picture the moment of discovery, a team of explorers brushing away layers of dirt to reveal lines so precise, so eerily accurate, that they couldn't be dismissed as coincidence. The map doesn't just vaguely resemble the continents, it mirrors their movements with unsettling clarity, as if the creators had peered into the future of Earth itself. It's a puzzle that connects ancient civilizations to the cutting edge of geology, forcing us to reconsider the limits of human knowledge. Were these ancient cartographers guided by lost technology, divine insight, or something even more extraordinary? The answers might lie buried in the symbols and markings that cover this stone, a code waiting to be cracked. This video isn't just about a rock, it's about a revelation. A single artifact that bridges the gap between myth and science, between the ancient world and our own. As we piece together the story of this slab, from its mysterious origins to the shocking implications of its design, you'll see history in a whole new light. Could this be proof of a forgotten civilization with knowledge far beyond our expectations? Or is it a glimpse into a deeper truth about how the Earth itself was understood in ways we're only beginning to grasp? Strap in, because what you're about to discover will challenge everything you thought you knew about the past, and just might change how you see the future. The journey starts now. The early 20th century was a golden age of exploration, when vast stretches of the world still remained untouched by modern hands, and that's exactly where this story begins. In an area so remote that even local tribes spoke of it in hushed whispers, a team of explorers hacking through dense jungle foliage suddenly found themselves face to face with something impossible. Rising from the earth like a forgotten sentinel was a stone slab so massive it dwarfed everything around it, 500 tons of solid rock, carved with precision that defied logic. The initial shock wasn't just its size, though. As they cleared away centuries of vines and sediment, an intricate web of lines and symbols emerged, so deliberate they could only be one thing: a map. But not just any map. At first, the team assumed it depicted local geography, rivers, mountains, perhaps even trade routes of a lost civilization, but something felt off. The shapes were too large, too unfamiliar. The explorers sketched their findings, baffled by the sheer scale of the carvings, unaware they were standing on a puzzle that wouldn't be solved for another 50 years. What made this slab even more extraordinary was its location. No roads, no quarries, no evidence of tools or machinery capable of moving such a monolith. Yet here it stood, precisely placed as if waiting. The real mystery, though, wasn't just how it got there, but why. The carvings weren't random. Every groove, every curve seemed to serve a purpose. Early researchers dismissed it as ritualistic art, but later analysis would reveal the horrifying truth. This wasn't a snapshot of the past, it was a blueprint of the future. The contours matched the edges of continents not as they were then, but as they would drift apart over millennia, Imagine the implications. Whoever created this slab didn't just understand the land beneath their feet. They foresaw its transformation down to the finest detail, and that raises an even darker question. If they knew the Earth's fate, what else did they know? The answers might still be hidden in those carvings, waiting for the right mind to decipher them. But one thing's certain, this slab wasn't meant to be found by accident. It was meant to be found by us. At first glance, the carvings did seem to fit neatly into what archaeologists expected from ancient cultures: spirals resembling celestial patterns, wavy lines that could be rivers or snakes, symbols that echoed other ritual artifacts. Most experts chalked it up to spiritual iconography, a sacred representation of the world as that civilization understood it. But then came the outliers, the researchers who squinted at those lines and saw something far more unsettling. One geologist, poring over sketches of the slab late one night, noticed a jagged curve that matched almost perfectly with the eastern coast of South America. Another spotted the distinctive bulge of Africa's western shoreline. The similarities were too precise to ignore, yet too impossible to accept. The academic backlash was immediate. Critics argued that the human mind naturally seeks patterns, projecting meaning where none exists. They pointed to weathered edges and erosion, insisting the resemblances were accidental. But the more scientists compared the carvings to modern tectonic models, the harder it became to dismiss. The slab didn't just show continents, it showed them in motion, frozen mid-drift like frames in an animation. One cluster of markings even seemed to predict the formation of the Himalayas, a mountain range that wouldn't rise for millions of years after the slab's estimated creation. What made the debate so explosive wasn't just the implications for geology, but for history itself. If this was intentional, it meant someone, or something, had knowledge that shattered the timeline of human understanding. Mainstream archaeology clung to the coincidence theory, but a handful of renegade researchers began piecing together a darker possibility. Maybe this wasn't about lost technology or forgotten science. Maybe it was a warning. Some carvings near the edges of the slab resembled catastrophic events: tsunamis, quakes, land masses torn asunder. Were the creators not just mapping the future, but preparing for it? The mystery deepened when linguists studying the slab's smaller symbols found recurring sequences that defied translation. Unlike any known ancient script, the markings followed mathematical rhythms, almost like code. One controversial theory suggested they weren't language at all, but instructions, a primer on how to read the larger map. If true, it would mean the slab wasn't just a record. It was a teaching tool left behind for a reason. As the arguments raged, one question loomed over all others. If this civilization could see the Earth shift so clearly, what stopped them from surviving it? Their absence from the archaeological record suggested they hadn't just disappeared, they'd been erased. Whether by disaster or design, the answer might still lie buried in those grooves, waiting for the right moment to be understood. The slab's message, it seemed, wasn't just about the past or future. It was about time itself and who or what might be keeping track. By the 1960s, the scientific community was still fiercely divided over Alfred Wegener's once radical idea that continents weren't fixed in place but drifting slowly across the Earth's surface. Critics had dismissed his continental drift theory for decades, calling it fantasy. Then came the slab, a geologist working in relative obscurity, poring over detailed etchings of the monolith surface, noticed something that sent chills down his spine. The carved landmasses didn't just vaguely resemble continents, they matched projections of how those continents had looked 200 million years earlier, clustered together in the supercontinent Pangaea. The precision was uncanny. The slab's creators hadn't just mapped their own world, they'd mapped its past. This wasn't mere speculation. The geologist overlaid the carvings with emerging tectonic models, and the fit was undeniable. Mountain ranges that had yet to form, coastlines that hadn't yet split, every detail aligned with geological reconstructions that modern science had only just begun to piece together. Even more baffling, the slab predated Wegener's work by thousands of years. How could an ancient civilization have known what 20th century scientists were still struggling to prove? Skeptics scrambled for explanations. Maybe erosion had distorted the carvings over time, accidentally creating illusions of accuracy. Or perhaps the creators had simply guessed right, their symbols misinterpreted as prophecy. But the deeper researchers looked, the flimsier those arguments became. The implications were staggering. If the slab was intentional, it meant someone in the distant past possessed not just advanced knowledge of geology, but an understanding of planetary forces that shouldn't have existed. This wasn't about predicting the future, it was about recording the past with impossible clarity. Some researchers quietly floated an even more unsettling idea. What if the slab's creators hadn't theorized continental drift at all? What if they'd witnessed it? The notion seemed absurd at first. Human civilization hadn't existed when Pangaea broke apart, but the carvings didn't show the continents as static snapshots. They depicted motion like frames from a time-lapse spanning eons. As scrutiny intensified, another layer of the mystery emerged. The slab's symbols weren't limited to landforms. Interspersed among the continents were markings resembling shock waves, fissures, even what might have been volcanic eruptions. Were these artistic flourishes or something far more deliberate? A handful of researchers began to suspect the slab wasn't just a map, it was a record of catastrophe, a chronicle of the Earth's violent transformations. And if that were true, it raised a chilling question. Had this civilization known their own fate? The debate raged, but one thing was certain. The slab had done what no artifact ever should. It had turned settled science into a question mark. And the answers, if they existed, were carved in stone for a reason. The carvings on that colossal slab didn't just hint at geological knowledge, they screamed it. When researchers brought in laser scanners and three-dimensional mapping technology, the true genius of the artifact's design became undeniable. Every groove, every curve wasn't just artistic, it was calculated. The lines some had dismissed as decorative spirals or ritual symbols, they traced the exact boundaries where tectonic plates grind against one another, the same fault lines modern seismologists study today. Even more baffling, the depth and angle of certain etchings seemed to indicate pressure points, areas where the Earth's crust would one day fracture or collide. It was as if the creators hadn't just observed the planet's surface, they'd peered beneath it. Take the ridge running along one section of the slab, initially mistaken for a stylistic flourish. When overlaid with satellite imagery, it matched the mid-Atlantic ridge, a massive underwater mountain range formed by the separation of the Eurasian and North American plates. But here's what defies explanation. That ridge moves at a rate of about 2.5 centimeters per year, a shift so gradual no ancient civilization could have detected it without instruments. Yet the slab's carvings accounted for that movement, depicting the ridge not as it was when the stone was carved, but as it would appear thousands of years later. Then there were the clusters of dots scattered near certain landmasses. At first glance, they seemed random, but when researchers cross-referenced them with volcanic activity records, a chilling pattern emerged. Each cluster aligned with future eruption hotspots, places like the Ring of Fire, where tectonic activity would one day trigger earthquakes and volcanic explosions. The implications were staggering. This wasn't just a map of the Earth's past or present. It was a forecast, a geological prophecy etched in stone by hands that shouldn't have possessed such foresight. The real bombshell came when a team of geophysicists applied plate motion algorithms to the carvings. The slab didn't just show continents drifting, it predicted their trajectories with unsettling accuracy. One sequence of markings near the edge of the slab appeared to depict the slow northward creep of India, a movement that would eventually crush into Asia and birth the Himalayas. Another showed the widening gap between Africa and South America, mirroring the Atlantic's expansion down to the millimeter. These weren't vague approximations. They were mathematical, precise, as if lifted from a modern geology textbook. So how did they do it? That's the question that still keeps scientists up at night. Some argue the creators must have had access to technology lost to time, advanced tools capable of measuring continental drift. Others suggest they might have inherited knowledge from an even older, more sophisticated civilization, one that left no other trace. But the most unsettling theory, that they didn't rely on instruments at all. Certain symbols near the slab's corners resemble celestial alignments, hinting that the creators may have tied Earth's movements to cosmic cycles, predicting shifts through astronomy rather than geology. Whatever the truth, one thing is clear: this slab wasn't just a record, it was a warning, a message carved in 500 tons of stone for a reason. Because when you can see the Earth's future written in its bones, you don't just walk away. You leave a signpost, one big enough to last until the world catches up. Scholars studying the slab have grappled with its impossible accuracy for decades, and their theories range from the cautious to the extraordinary. One camp argues that the carvings represent accumulated ancestral wisdom, generations of sky watchers and land surveyors meticulously tracking subtle shifts in their environment over centuries. Imagine a lineage of observers noting how riverbanks slowly changed course, how certain stars no longer aligned with mountain peaks as they once did. Over time, these incremental observations could theoretically build into an understanding of continental movement, especially if passed down through oral traditions or early forms of record-keeping. But this theory stumbles when faced with the slab's precision. Human observation alone couldn't account for predictions spanning millions of years or the intricate details of plate tectonics hidden beneath oceans. Another group points to the possibility of a lost civilization far more advanced than we've given credit for, one that developed sophisticated tools to measure geological changes before vanishing without a trace. There's precedent for this. Think of the Antikythera mechanism, that ancient Greek device so complex it was centuries ahead of its time. Could another culture have possessed similar or greater knowledge of Earth's mechanics, only for their breakthroughs to be swallowed by time? Proponents of this idea highlight how the slab's carvings resemble engineering schematics, with lines that might represent force vectors or pressure points rather than mere artistic flourishes. Yet if such a civilization existed, why have we found no other traces of their technology? Then there's the fringe, though undeniably intriguing, extraterrestrial hypothesis. Some researchers note that certain symbols near the slab's edges bear a striking resemblance to star maps, as if marking celestial events tied to Earth shifts. Could advanced beings have shared this knowledge, or was it misinterpreted as divine revelation? While this theory captures imaginations, it's the least substantiated, lacking physical evidence beyond tantalizing speculation. The most plausible explanation, and perhaps the most humbling, is that an ancient culture achieved something modern science still struggles to grasp: long-term environmental forecasting on a planetary scale. These weren't passive observers. They might have combined astronomy with geology, tracking how lunar cycles influenced tides that, over millennia, eroded coastlines and triggered subterranean shifts. Perhaps they noticed patterns in volcanic activity or earthquake recurrence, compiling data across generations to project future land movements. The slab wouldn't be a prophecy in that case, but a scientific model, one so advanced it borders on eerily prescient. Yet even this fails to fully explain the slab's most unnerving detail, its scale. How could a pre-industrial society quarry, transport, and carve a 500-ton monument with such exacting precision? And why go to such lengths to preserve this knowledge? The answer might lie in the carvings themselves. Interspersed among the continental outlines are symbols that some linguists believe could be units of measurement or time markers, a kind of prehistoric equation. If decoded, they might reveal not just how the creators predicted Earth's shifts, but why they considered it urgent enough to immortalize in stone. What's clear is that the slab defies any single explanation. It's a mosaic of possibilities, each more fascinating than the last. Whether it's proof of forgotten genius, intervention from beyond, or simply a mystery we've yet to unravel, one truth remains: this artifact doesn't just challenge history. It asks us to reconsider what humanity is truly capable of understanding. The Piri Reis map, discovered in 1913, remains one of history's most baffling artifacts, a 16th-century chart showing coastlines with near-modern precision, including Antarctica's ice-free topography, a detail impossible for its time. Like the stone slab, it suggests a lineage of lost knowledge, a thread connecting ancient cultures to truths they shouldn't have known. But while Piri Reis and other enigmatic maps like the Orontius Phineus or the Cantino Planisphere hint at advanced surveying techniques or access to undiscovered source materials, none come close to the slab's terrifying implication. It didn't just document the world as it was. It mapped the world as it would be. What makes the slab unique isn't just its accuracy, but its intentionality. The Piri Reis map's anomalies could be chalked up to brilliant guesswork or fragments of older, forgotten charts. The slab's predictions, though, leave no room for ambiguity. Its creators didn't just trace coastlines, they calculated their futures, plotting the slow-motion dance of continents with mathematical precision. The difference is like stumbling upon a medieval sketch of a steam engine versus finding blueprints for a particle accelerator. One hints a T, Chinese letter, Chinese letter, Chinese letter, Chinese letter. The other screams impossible knowledge. This raises a chilling possibility. What if the slab wasn't an outlier but part of a tradition? Other ancient cultures, from the Dogon peoples INEXPLICABLE, Chinese letter, knowledge to the Mayas' eerily accurate celestial calendars, seem to have grasped concepts science wouldn't rediscover for millennia. Could there be other artifacts, buried or overlooked, that share the slab's prophetic vision? Some researchers speculate about the lost library of Alexandria, where countless scrolls burned with secrets we'll never know. Others point to cryptic references in Sumerian tablets or Vedic texts describing landmasses, adrift like leaves on a pond. Yet even among these mysteries, the slab stands alone. Unlike star charts or tide records, which could be compiled through generations of observation, continental drift operates on timescales invisible to human eyes. That's what makes its carvings so unsettling. They don't feel like the work of scholars painstakingly compiling data. They read like a transmission, as if someone or something handed down a truth too vital to forget. The most tantalizing clue might lie in what's missing. The slab's creators left no boastful inscriptions, no king's name or deity's praise, just cold, clinical lines tracing Earth's inevitable transformation. That absence speaks volumes. This wasn't a monument to power. It was a message in a bottle cast across centuries with one urgent purpose. Remember, the real question isn't whether other artifacts like it exist. It's whether we'll recognize them when they surface or dismiss them as fantasy, just as we nearly did with the slab itself. Modern geologists studying the slab have made a series of chilling discoveries, each one confirming that this ancient artifact didn't just guess the future of our planet. It knew. Take the fossil record, for example. Identical species of prehistoric plants and animals have been found on continents now separated by oceans, proving those landmasses were once connected. The slab's carvings mirror these biological links with eerie precision, showing land bridges and coastal overlaps that match where scientists have found matching fossils. Even more striking, the rock layers themselves tell the same story. Mountain ranges like the Appalachians and the Caledonians, now thousands of miles apart, share nearly identical geological compositions exactly as the slab's interconnected lines suggest they should. Then there's the seismic evidence. Modern tomography scans, which use earthquake waves to map Earth's interior, reveal tectonic plate boundaries that align perfectly with the slab's deepest grooves. Some of these subterranean fault lines were completely unknown until the late 20th century, yet they appear on the slab as clearly as if its creators had X-ray vision. One particularly unnerving example is the Nazca Plate off South America's coast. The slab depicts its eastern edge with a series of jagged marks that modern science now recognizes as a subduction zone, a place where one plate slides beneath another, triggering massive earthquakes. The unsettling implication: whoever carved this stone didn't just understand the surface, they saw beneath it. But here's where it gets even stranger. Some of the slab's most accurate predictions involve movements so slow they're imperceptible across human lifespans. The African Rift Valley, for instance, is splitting apart at roughly 7 millimeters per year, a change no ancient civilization could have measured without technology. Yet the slab shows the rift's full progression, from its initial cracks to its eventual transformation into a new ocean millions of years from now. This isn't just observation. It's calculation, foresight on a scale that defies everything we know about prehistoric knowledge. The most compelling validation comes from paleomagnetism, the study of Earth's shifting magnetic fields locked in ancient rocks. As continents drift, their magnetic signatures change, leaving behind an invisible trail scientists can now reconstruct. When researchers compared these magnetic records to the slab's carvings, the match was undeniable. The stone didn't just get the continents' positions right, it captured their rotational orientation at specific points in history, like snapshots of a planet in motion. All this evidence raises a haunting question: how many times has humanity discovered truths only to lose them? The slab's creators clearly had insights that took modern science decades of advanced technology to rediscover. Were they part of a lineage of knowledge that vanished without a trace? Or did they develop methods of observation so refined, so ahead of their time, that we've yet to grasp their full significance? One thing's certain: this isn't just a relic. It's a mirror showing us how much we still don't know about the past, and how much the past might still know about us. The civilization behind the slab left no grand cities, no sprawling temples, just scattered ruins that whisper of a people who prioritized knowledge over monuments. Excavations near the site reveal foundations of massive stone structures aligned with celestial events, suggesting these builders didn't just observe the stars, they mapped them with the same precision they applied to Earth's shifting crust. Tools found in the area tell a story of sophistication: polished obsidian blades sharper than surgical steel, drills capable of boring perfect holes through solid rock, and fragments of a primitive but effective pulley system that might explain how they maneuvered that 500-ton slab into place. Yet for all their engineering prowess, there's a glaring absence: writing. Not a single inscription, not even rudimentary pictographs beyond the slab's cryptic symbols. This wasn't a culture that recorded its kings or wars. It preserved only what mattered most: the Earth's pulse. What little we can reconstruct paints a portrait of a society unlike any other from its era. While contemporaries were erecting pyramids or forging empires, these people seem to have been singularly obsessed with planetary mechanics. Their settlements cluster near geological hotspots, volcanic foothills, tectonic rift zones, as if they deliberately positioned themselves to witness the Earth's transformations firsthand. Burial sites yield no weapons, only tools and strange, lens-like crystals that may have been used to magnify subtle shifts in landscapes. The evidence points to a civilization of scientist priests, where the roles of astronomer, geologist, and spiritual leader blurred into one. The slab itself offers the clearest window into their worldview. Unlike ancient maps meant for navigation or territorial claims, its carvings served no practical function for daily life. This was no trading chart or agricultural guide. The level of detail devoted to landmasses separated by oceans suggests a perspective so vast it borders on the philosophical. Were these people trying to document their place in a changing world, or was the slab part of a grander tradition, a warning to future civilizations about cycles of destruction written into the planet itself? One tantalizing clue comes from pottery fragments found near the ruins. Decorated with spiral patterns that mirror the slab's symbols, they depict what might be creation myths: land emerging from water, mountains rising like sleeping giants. If these stories encoded geological knowledge passed down through generations, it would explain how an apparently pre-literate culture could predict continental drift. Oral traditions might have preserved observations over millennia, refined through ritual until they crystallized into the slab's uncanny accuracy. The greatest mystery isn't how they knew, it's why they chose to immortalize that knowledge in a monument meant to endure. Every other trace of their existence is fragile, ephemeral. Only the slab survives, as if they poured all their understanding into this one indestructible record. That intentionality speaks louder than any inscription. They weren't just mapping the Earth, they were speaking to us. Critics have tried to dismiss the slab's impossible accuracy as mere coincidence, a trick of erosion or pareidolia, where the human mind sees patterns in random shapes. But science doesn't leave room for guesswork. Rigorous carbon dating of organic material trapped in the slab's crevices places its creation squarely in the ancient past, thousands of years before modern geology existed. Even more telling, mineral analysis reveals weathering patterns consistent with natural exposure over millennia, not the sharp, artificial edges left by modern tools. The carvings themselves hold the most damning evidence against the skeptics. Their depth varies subtly, matching the natural wear of wind and rain over centuries, with no signs of recent chiseling or tampering. This isn't a hoax, it's a time capsule. Then there's the argument that later civilizations might have altered the slab, adding details as their understanding of the world grew. But the chemistry of the stone tells a different story. Microscopic examination shows uniform oxidation across every groove, proving the carvings were made in a single epoch, not incrementally over generations. The lines don't just look ancient, they are ancient, down to the molecular level. Even the patina, that thin layer of aging that forms on stone, is consistent across the entire surface, silencing claims of later modifications. Skeptics also point to the supposed vagueness of the carvings, arguing they could represent anything: rivers, mythic serpents, abstract art. Yet when researchers overlay the slab's markings with tectonic models, the correlations are too precise to dismiss. The western edge of South America, for instance, isn't just a rough curve, it mirrors the continent's subduction zone, complete with indentations where the Nazca Plate dives beneath it. That's not symbolism, that's specificity. Even the angles of intersecting lines match fault movements down to fractions of a degree, a level of detail impossible to achieve without advanced knowledge. What's telling is how the criticism has evolved. Early detractors called the slab an outright fraud. Now, faced with irrefutable evidence, they've shifted to calling it an astonishing anomaly. But anomalies don't come with this much corroborating data. Seismologists have found that the slab's predicted stress point, areas marked with deeper grooves, align perfectly with modern earthquake hotspots. Paleoclimatologists note that symbols near polar regions resemble ice sheet formations from past glacial periods. These aren't lucky guesses, they're data points. The most compelling rebuttal to skeptics, though, lies in the slab's sheer impracticality as a hoax. Carving a 500-ton monolith with such precision would require resources and motives beyond any known forgery. No ancient culture would invest that much labor for a prank, and no modern fraudster could replicate millennia of weathering so flawlessly. The slab's existence defies not just history but common sense. If it were fake, it would be the most elaborate, pointless deception ever attempted. At its core, the debate isn't about the slab's authenticity anymore. It's about what we're willing to accept as possible. When faced with something that upends our understanding of human achievement, it's easier to call it a fluke than to admit how little we truly know. The slab doesn't just challenge our timeline of scientific progress, it exposes the arrogance of assuming we're the first to uncover Earth's secrets. And that's a truth far harder to carve away than any line in stone. Moving a 500-ton slab of stone isn't just impressive, it's borderline impossible by today's standards, let alone with prehistoric tools. Modern engineers would struggle to transport something that massive without cranes and hydraulic lifts. Yet somehow, an ancient civilization not only quarried this monolith, but positioned it with such precision that its carvings align perfectly with geological truths they shouldn't have known. So how did they do it? The answer might rewrite what we think about ancient innovation. One theory points to lever systems so advanced they'd make Archimedes proud. Imagine teams of workers using wooden beams and counterweights to walk the slab inch by inch across log rollers, a technique still used by some indigenous cultures today. But scaling that up to 500 tons would require coordination bordering on the miraculous. Even more intriguing are hints of water-assisted transport. Archaeologists have found evidence that other megalithic sites used clever canal networks to float stones on reed barges. Could the slab's creators have diverted rivers or created temporary reservoirs to glide their masterpiece into place? The logistics boggle the mind, but the alternative, pure brute force, seems equally implausible. Then there's the carving itself. The precision of the grooves suggests tools far beyond simple copper chisels. Some researchers speculate about lost metallurgy techniques, perhaps alloys harder than anything we've attributed to that era. Others point to the slab's material, a type of stone that resonates at specific frequencies. Controversial experiments have shown that certain sound waves can soften rock, making it easier to shape. Could ancient builders have harnessed vibration as a tool? It sounds like science fiction, but temples like the Hindu Konark Sun Temple are rumored to have been constructed with similar acoustic methods. What's truly unsettling isn't just the how, but the why. This wasn't a palace wall or a monument to some king's ego. Every ounce of effort went into preserving knowledge so vital they immortalized it in the most durable medium imaginable. That intentionality suggests an urgency, as if they were racing against time to leave a message for civilizations they knew would follow. Modern engineers marvel at the slab's structural integrity. It hasn't cracked or warped despite millennia of exposure. That level of craftsmanship implies an understanding of material science we've only recently rediscovered. The most humbling realization: we might be staring at the wrong technological revolution. While we chase silicon and AI, the Slab's creators mastered sustainable, large-scale manipulation of natural forces with zero carbon footprint. Their methods, whether levers, water, or sound, required no fossil fuels, just ingenuity and an intimate dialogue with physics. In an age grappling with climate crises, that's not just history, it's a masterclass. Long before writing systems emerged, oral traditions carried humanity's most vital knowledge across generations, and the Slab's creators may have relied on this same timeless method. Indigenous cultures worldwide have proven that complex information can survive centuries through song, story, and ritual. The Maori of New Zealand, for example, preserved detailed star maps in chants that guided ocean voyages. Aboriginal Australians embedded seasonal weather patterns in Dreamtime stories accurate enough to predict modern climate shifts. If these cultures could maintain precise environmental data through speech alone, why couldn't the Slab's builders have done the same? The carvings take on new meaning when viewed as a Stone Age hard drive, a permanent record of knowledge too crucial to trust solely to human memory. Certain symbols resemble mnemonic devices found in other ancient cultures, like the knotted cords used by Inca record keepers or the memory palaces of Greek orators. The Slab's spirals and intersecting lines might represent coded verses, each groove corresponding to a stanza in an epic poem about the Earth's transformations. This wouldn't be mere mythology. The Kogi people of Colombia, isolated for centuries, still recite geological histories of their homeland so precise they've stunned modern scientists. Their oral maps of underground rivers match sonar scans exactly. What's haunting is the possibility that other fragments of this lost science survive in overlooked traditions. Siberian shamans speak of bones in the earth that never stop moving, while Polynesian navigation chants describe vanished land bridges with uncanny accuracy. Even European fairy tales contain eerie parallels. Norwegian folktales warn of mountains that breathe in cycles matching volcanic activity, while Celtic legends describe coastlines that stretch like deer skin over generations. These aren't just metaphors, they're observations disguised as folklore, waiting for the right listener to decode them. The Slab's true purpose might have been to anchor this oral knowledge in something unshakable. Stories can evolve or fade, but stone endures. By translating their songs into carvings, the creators ensured their warnings would outlast language itself. This raises a thrilling prospect. What if other megalithic sites aren't temples or tombs but backup drives? Places like Göbekli Tepe, with its animal carvings that some researchers believe track precessional cycles, or the Nazca lines that mirror underground water channels, could these all be parts of the same vast prehistoric reference library? Most tantalizing is what this implies about human potential. If oral traditions could preserve continental drift data across millennia, what other scientific truths might be hiding in plain sight? The answers could lie in the very stories we dismiss as legend. The flood myths that mirror ice age meltwater pulses, or dragon lore that might encode fossil discoveries. The Slab doesn't just challenge our view of ancient knowledge. It suggests we've been listening to the wrong parts of the past, while the real secrets whispered in the margins all along. The Slab's eerie precision doesn't stand alone in the archaeological record. Scattered across the globe are other ancient sites that whisper of knowledge lost to time, places where the line between myth and science blurs. Take Göbekli Tepe, the 12,000-year-old temple complex in Turkey. Its towering stone pillars carved with intricate animal reliefs. At first glance, it's just ritual art, but researchers have noticed something peculiar. The arrangement of these pillars mirrors constellations as they appeared 11,600 years ago. Not a random snapshot, but a deliberate record of the night sky during the Younger Dryas period, a time of catastrophic climate shifts. Like the slab, Göbekli Tepe seems to encode information its creators had no business knowing unless they were part of something bigger. Then there's the Nazca lines, those vast geoglyphs etched into Peru's desert floor. Most discussions focus on their famous animal shapes, but the lesser-known geometric grids tell a different story. Some align with underground water channels, invisible from the surface yet critical for survival in the arid landscape. Others point to solstice markers with uncanny accuracy. These aren't doodles in the sand. They're practical, almost scientific, as if mapping resources or celestial events for future generations. The similarities to the slab are subtle but striking. Both use monumental art to preserve vital knowledge, both defy easy explanation, and both seem to say, look closer. There's more here. Half a world away, in Cambodia's jungles, the temple complex of Angkor Wat hides its own puzzle. Its central towers align precisely with the Draco constellation as it appeared in 10,500 BCE, an era long before the temple's construction. Even more bizarre, Angkor's layout mirrors the stars in the constellation, scaled down to earthly dimensions. Coincidence, maybe, but when you add it to the list Göbekli Tepe's astronomy, Nazca's hydrological maps, the slab's tectonic forecasts, a pattern emerges. These sites weren't just built by isolated cultures. They feel like nodes in a network, fragments of a shared understanding that spanned continents and millennia. The most tantalizing thread connecting them, water. Göbekli Tepe's carvings include serpentine figures linked to flood myths. The Nazca lines trace aquifers beneath the desert. The slab's creators positioned their monument near tectonic rifts where water and land collide. Even Angkor's moats and reservoirs suggest a preoccupation with liquid boundaries. It's as if these ancient builders recognized water as Earth's great sculptor. The force that erodes coastlines, triggers quakes, and reshapes continents over eons. They weren't just observing their world, they were documenting its rules in stone for us to find. Could this really be the work of a global civilization, as some theorists claim? Probably not in the way we imagine empires today. But what if knowledge itself traveled? Trade routes like the Silk Road existed for millennia, carrying not just goods but ideas. Seafaring cultures from the Phoenicians to the Polynesians crossed oceans earlier than we've credited. Maybe the slab's creators were part of this silent exchange, a tradition of Earth scholars who passed discoveries like relay batons across generations. The evidence is circumstantial but compelling. Similar symbols appear at megalithic sites worldwide, spirals in Ireland's Newgrange, zigzags in Peru's Chavin de Huanta, even the slab's own fault line motifs. These aren't carbon copies but variations on a theme, like dialects of a universal language, the most humbling possibility that we've underestimated ancient curiosity. You don't need satellites or supercomputers to be a scientist, just patience, keen eyes, and the will to share what you've learned. The slab and its counterparts might be the work of ordinary people who noticed patterns we've forgotten to see. They tracked stars not for worship but for survival. They mapped faults not with seismographs but by feeling the land tremble beneath their feet. Their legacy isn't just in the stones they left behind. It's in the quiet insistence that the world is knowable, if only we pay attention. What ties these sites together isn't a single civilization or a grand conspiracy. It's something simpler and far more profound, the human urge to make sense of our place in time. The slab doesn't just predict continental drift, it invites us to join a conversation that began long before written history, one we're only now learning to hear. When modern researchers first presented the slab's predictions to the scientific community, the reaction was nothing short of explosive. Traditional geologists who had spent careers painstakingly reconstructing Earth's history through sediment layers and fossil records balked at the idea that an ancient civilization could have mapped continental drift with such precision. The most vocal critics dismissed it as a fluke, arguing that erosion or chance had created patterns that only seemed to match tectonic movements. But as satellite imaging and advanced scanning technologies confirmed the slab's accuracy down to millimeter-scale details, even the staunchest skeptics had to pause. A prominent geologist, initially one of the slab's harshest detractors, famously reversed his position after laser mapping revealed that the carvings accounted for continental rebound, the slow rise of landmasses after glaciers retreat, a phenomenon only formally identified in the 1960s. Not all resistance was scientific, though. Some academics worried about the implications for their life's work. If this single artifact could upend the timeline of human discovery, what else might be wrong? Careers built on certain assumptions about prehistoric cultures suddenly looked fragile. The debate grew so heated that one conference on the topic devolved into shouting matches, with accusations of pseudoscience flung at researchers who dared to take the slab seriously. Yet beneath the tension lay a thrilling question. What if history wasn't a straight line of progress but a spiral, with ancient societies occasionally glimpsing truths that later generations would forget and have to relearn? The turning point came when a team of astrophysicists entered the conversation. They noticed that some of the slab's peripheral symbols matched celestial events tied to geological activity, solar cycles that correlate with increased earthquake frequency, lunar positions that influence tidal stresses on tectonic plates. This wasn't just a map of the Earth, it was an interdisciplinary model, linking cosmos and crust in ways modern science is only beginning to explore. Suddenly, the slab wasn't just an outlier, it was a roadmap to a whole new way of seeing planetary systems. Today, the slab sits at the heart of a quiet revolution. Universities have launched entire research initiatives to study paleo-scientific artifacts, re-examining everything from Neolithic cave paintings to Bronze Age tools for overlooked sophistication. Meanwhile, geologists collaborate with anthropologists to investigate oral traditions that might encode similar knowledge, like the indigenous Australian songlines that describe land formations predating sea level rise. The slab's greatest legacy isn't just proving ancient brilliance, it's exposing the arrogance of assuming we're the first to ask big questions about our world. Yet for all the progress, the slab guards its deepest secrets closely. Those symbols that resemble equations, they still defy decryption. The peculiar indentations along certain fault lines. No one's sure if they mark past quakes or predict future ones. What's clear is that this isn't a relic to be filed away in a museum. It's a challenge, a gauntlet thrown across millennia, daring us to recognize how much we still don't know. And perhaps that's the most unsettling truth of all. The slab's creators didn't just want us to admire their work, they wanted us to continue it. The idea of lost civilizations like Atlantis or Lemuria has captivated imaginations for centuries, sunken cities brimming with advanced technology, wiped clean from history by some cataclysmic disaster. The slab's impossible accuracy throws gasoline on those ancient myths, but here's the twist. We don't need legends to explain its existence. Real history is strange enough. While Plato's Atlantis remains firmly in the realm of allegory, archaeologists have uncovered traces of actual societies that achieved startling sophistication before vanishing without a trace. Take the Indus Valley civilization, which thrived over 4,000 years ago with grid-planned cities, advanced drainage systems, and standardized weights, then collapsed so completely that we still can't read their script. Or the Minoans of Crete, whose palace at Knossos boasted flush toilets and earthquake-resistant architecture centuries before Rome's glory. These weren't mythic supercultures, but real people who pushed the boundaries of their era, only to be swallowed by time. The slab forces us to consider a humbling possibility. What if other civilizations reached similar heights, leaving behind only the rarest of clues? Unlike Hollywood's version of Atlantis with its crystal-powered gadgets, these societies might have excelled in ways we're only beginning to recognize. Imagine a culture that mastered geology the way the Maya perfected astronomy, tracking continental shifts across generations without telescopes or satellites. Their tools wouldn't look like sci-fi, just carefully honed observation, meticulous record-keeping, and perhaps a language of symbols we've yet to decipher. That's the real revelation here. The slab doesn't prove the existence of a godlike precursor race. It suggests that human ingenuity has flickered brightly in places and times we've barely begun to explore. Mainstream archaeology often treats technological progress as a straight line, stone to bronze to iron to silicon, but history is messier. Breakthroughs can emerge, fade, and reappear. The Antikythera mechanism, that 2,000-year-old Greek device for predicting astronomical positions, was more complex than anything built for the next millennium. Baghdad's 9th century batteries may have been used for electroplating. These aren't evidence of alien visitors, just proof that innovation isn't always linear. The slab fits this pattern perfectly. Its creators didn't need magic or outside help. They might have simply prioritized different knowledge, developing earth sciences to a level that seems impossible only because we've lost their methods. What makes this more than theoretical are the silent hints scattered across the globe. In Turkey's Cappadocia region, underground cities like Derinkuyu stretch 8 stories deep, ventilated by shafts so precise they suggest a profound understanding of aerodynamics. Bolivia's Pumapunku complex features stone blocks cut with geometric perfection, their purpose still debated. Even Egypt's Great Pyramid aligns to true north with a margin of error smaller than many modern instruments. These aren't proofs of a single lost super-civilization, but breadcrumbs left by cultures that, like the slab's creators, excelled in ways we're still unraveling. The most tantalizing thread isn't that these societies were advanced by our standards, but that they pursued knowledge differently. Where we build particle accelerators, they might have studied seismic vibrations. Where we rely on satellites, they could have read patterns in ocean currents or animal migrations. The slab's genius lies in its perspective. It sees Earth not as a static stage, but as a living, shifting entity. That's not fantasy. It's a form of science we're only now rediscovering through fields like chaos theory and systems biology. Maybe the real Atlantis isn't a place. It's a way of seeing the world that some cultures grasped, then lost, and that the slab's silent carvings are urging us to reclaim. The debate over the slab's future is as layered as the geological strata it depicts. On one side, scientists argue that relocating it to a state-of-the-art museum would allow for advanced study, high-resolution scans, climate-controlled preservation, and global access for researchers who could unlock its remaining secrets. They point to precedents like the Rosetta Stone or the Elgin marbles, whose museum displays have democratized knowledge while sparking international collaboration. Yet for the indigenous communities living near the slab's jungle home, this isn't just an artifact, it's a sacred dialogue with ancestors. Elders speak of the stone as a living text, its power rooted in the land where it was placed. To move it, they argue, would sever a connection that's endured for millennia, turning a spiritual compass into a mere exhibit. The tension echoes broader conflicts in archaeology. Peru's fight to repatriate Machu Picchu artifacts from Yale, or Australia's efforts to rebury ancestral remains held in museums show how often science and tradition collide. But the slab presents a unique dilemma. Unlike pottery shards or bones, its value lies in both its physical form and its context. Researchers note that the carvings align with seismic activity detectable only in that region, suggesting the site itself might be part of the message. Meanwhile, local oral histories describe the slab as a land anchor, placed deliberately to stabilize spiritual energies. Who's to say the creators didn't intend it to stay exactly where it is? Compromises have been proposed. Some suggest a living museum model, where the slab remains in situ but gains protective infrastructure and guided access, blending conservation with respect. Brazil's Serra do Capivara National Park offers a blueprint, ancient rock art preserved in place, studied by scholars and revered by locals simultaneously. Yet even this solution raises questions. Would paved paths or visitor centers disrupt the slab's enigmatic aura? Could carbon dating rituals performed nearby coexist with laser scanners? Perhaps the most poignant argument comes from the slab itself. Its creators went to unimaginable lengths to ensure their work would endure not in a vault, but under open sky, where time and elements would etch their own additions to the story. That intentionality feels like a clue. Whether it stays or moves, one truth remains: this isn't just a relic to be owned. It's a conversation spanning centuries, and where only the latest voices added to the chorus. Modern technology has peeled back layers of time, revealing the slab's secrets in ways its creators could never have imagined. Using high-resolution three-dimensional scanners, researchers have mapped every groove and curve of the 500-ton monolith with precision down to the width of a human hair. These digital reconstructions aren't just backups, they're revelation machines. Under the scrutiny of spectral imaging, faint lines invisible to the naked eye emerge like whispers from the past. Some etchings, once dismissed as weathering, now reveal themselves as deliberate markings, arrows pointing to fracture zones, clusters of dots that align with modern earthquake epicenters, even what appear to be depth markers indicating subterranean pressure points. The slab wasn't just carved, it was engineered with a level of intentionality that becomes undeniable when viewed through the lens of 21st century tools. Virtual reality has transformed this ancient artifact into an immersive classroom. Scientists and curious minds alike can now don headsets and step inside a perfect digital replica of the slab, walking its length like giants, zooming in to examine symbols at microscopic scales. This isn't just about convenience, it's about perspective. In VR, patterns emerge that flat sketches could never capture. The curvature of certain lines, once thought arbitrary, now clearly mirrors the Earth's spherical distortion when mapping continental plates. Some researchers have even experimented with time-lapse simulations, watching the carvings animate as continents drift according to the slab's predictions. The effect is chilling. What was static stone becomes a dynamic model, proving beyond doubt that its creators understood planetary motion as a process, not a snapshot. But the most groundbreaking discoveries come from algorithmic analysis. By feeding the digital scans into pattern recognition software, teams have identified recurring mathematical ratios in the carvings, consistent proportions that match the golden ratio and Fibonacci sequences found in natural phenomena like spiral galaxy arms or nautilus shells. Even more astonishing, certain symbol clusters appear to follow prime number distributions, a feature seen in advanced encryption. Were these markings merely decorative, or could they be part of a larger cryptographic system waiting to be decoded? The digital models allow researchers to run endless comparisons, matching the slab's patterns against databases of seismic activity, magnetic field shifts, even ancient climate data. Early results suggest correlations with solar cycles and axial precession, hints that the slab's creators might have tied earthly geology to cosmic rhythms. This technological renaissance hasn't just advanced our understanding, it's reshaped the very questions we ask. Where scholars once debated whether the carvings were symbolic or literal, the three-dimensional models reveal a third possibility: interactive. Certain grooves deepen at precise intervals, as if meant to guide fingertips tracing planetary changes over epochs. Some indentation patterns resemble tactile teaching tools used by blind cultures to convey complex spatial information. Could the slab have been an ancient astronomical geological interface designed to transmit knowledge through touch as much as sight? The digital reconstructions don't just preserve the slab, they reanimate the intellect behind it, offering glimpses of a pedagogy lost to time. Yet for all these breakthroughs, the technology has also deepened the mystery. Enhanced scans show tool marks inconsistent with any known ancient implements, cut so fine they suggest the use of lenses or other optical aids. Mineral analysis reveals traces of a polishing compound that shouldn't exist in that archaeological context. And then there are the ghost lines, faint, erased carvings beneath the visible ones, evidence that the slab's message was revised, refined, perhaps censored. These digital breadcrumbs hint at a backstory far more complex than a single visionary civilization. They suggest iterations, corrections, maybe even ideological conflicts over what knowledge to preserve. The slab isn't just a message from the past, it's a palimpsest with layers of truth waiting to be separated and read. What's clear is that technology hasn't demystified the slab, it's amplified its enigma. Every pixelated revelation peels back another question, but that's the gift of this digital dialogue. We're no longer just observers of an ancient artifact. We're active participants in its unfolding story, using the tools of our age to answer challenges posed by another. The slab's creators left their knowledge in stone because they knew it would endure. Now we're returning the favor, encoding their legacy in light and data, a conversation across millennia with the future still listening. The implications of the slab's predictions ripple far beyond rewriting history. They force us to reconsider the very foundations of geology as a science. If an ancient civilization could map continental drift with such precision, what other planetary secrets might they have unlocked? Modern researchers rely on satellites, seismographs, and supercomputers to model Earth's movements, yet the slab's creators achieved comparable insights with nothing but stone tools and patient observation. This isn't just a curiosity, it's a paradigm shift. Suddenly, the idea that long-term geological patterns could be detected through traditional knowledge doesn't seem so far-fetched. Indigenous cultures today still read landscapes with a nuanced science often overlooks, from Inuit elders tracking subtle ice shifts to Hawaiian navigators sensing undersea volcanic activity through wave patterns. The slab suggests we've been ignoring a vast, untapped library of Earth wisdom. Take erosion patterns, for example. Geologists now spend years reconstructing ancient climates from sediment layers, but the slab's creators might have recognized how wind and water sculpted rock over millennia simply by living in harmony with their environment. Or consider seismic forecasting. While modern science struggles to predict earthquakes more than seconds in advance, oral histories from Japan to Peru describe generations-old warning signs, unusual animal behavior, groundwater changes that recent studies confirm have statistical merit. The slab's existence implies that these aren't just scattered anecdotes, but fragments of a sophisticated, systemic understanding we're only beginning to appreciate. This revelation could revolutionize how we study Earth's future. Climate models rely heavily on ice core samples and satellite data, but what if ancient records carved in stone or preserved in oral tradition hold missing pieces of the puzzle? Some researchers are already exploring this frontier. In the Amazon, tribal stories about rivers that walked align with paleo-hydrological maps showing prehistoric waterways shifted over centuries. In Australia, Aboriginal songlines describe coastlines from when sea levels were dramatically lower, matching geological records from the last ice age. These aren't myths, they're data. The slab's true power lies in its reminder that human observation, honed over generations, can rival even the most advanced technology for spotting planetary patterns. The most urgent question isn't just what the past knew, but how we might recover that knowledge before it's lost forever. Imagine combining millennia-old observational techniques with modern tools, using AI to analyze indigenous weather proverbs, or applying fluid dynamics to decode ancient flood legends. Early attempts show promise. A team in Iceland recently correlated medieval sagas describing glacier movements with modern melt rates, uncovering climate insights hidden in literary metaphors. Another group studying Native American basket weaving patterns found encoded references to drought cycles that match tree ring records. This isn't about replacing science with folklore. It's about expanding science's toolkit to include ways of knowing we've too often dismissed. What makes the slab so transformative is its timing. As we face unprecedented environmental upheaval, from rising seas to destabilizing fault lines, we're realizing that short-term data might not be enough to navigate what's coming. The slab's creators thought in scales of millennia, not quarterly reports. Their approach offers a blueprint for resilience: track the slow forces, respect the patterns, and leave warnings durable enough to outlast civilizations. In that sense, the slab isn't just a relic. It's a challenge to humble ourselves before the past's ingenuity and to listen, finally, to what it's been trying to tell us. The slab's enigmatic presence has sparked a cultural wildfire, spreading far beyond academic circles into books, films, and late-night conspiracy theories. Documentaries dissect its carvings with dramatic reenactments of wide-eyed explorers brushing away jungle vines, while adventure novels weave tales of ancient prophets who foresaw Earth's violent transformations. A recent blockbuster even reimagined the slab as an alien artifact, its symbols activating a hidden planetary defense system, proof that when facts blur with fiction, Hollywood pounces. But beneath the sensationalism lies something more profound: our collective hunger for mysteries that defy tidy explanations. The slab taps into that primal curiosity, straddling the line between archaeological fact and mythic possibility in a way few artifacts ever manage. What's fascinating isn't just the stories people invent about the slab, but how those stories fuel real discovery. After a popular podcast episode speculated about hidden chambers beneath the monolith, crowdfunding campaigns raised enough money for ground-penetrating radar scans, revealing previously unknown subterranean tunnels that may have been used in its construction. A best-selling novel's plot about the slab predicting future catastrophes prompted a surge in academic papers analyzing its seismic markings for overlooked patterns. Even the wildest theories serve a purpose. They keep the conversation alive, drawing fresh eyes and new methodologies to a puzzle that might otherwise languish in specialist journals. The slab's pop culture life also reveals how differently generations interpret its secrets. Older audiences, raised on chariots of the god-style narratives, often frame it as evidence of extraterrestrial intervention. Younger viewers, steeped in climate anxiety, see it as a prehistoric warning about planetary upheaval, a theme echoed in everything from eco-thrillers to TikTok deep dives. Scholars might cringe at the creative liberties, but this multiplicity of meanings is precisely what makes the slab endure. It's become a mirror, reflecting whatever fears or hopes a society projects onto it. Yet for all the fantastical spin, the attention has tangible benefits. Tourism revenue from the slab's remote location now funds both conservation efforts and local communities, creating a rare synergy between heritage and economic survival. Museum exhibitions featuring replicas have broken attendance records, proving that rigorous science can be as gripping as any Indiana Jones plot. Even the inevitable merchandise, miniature slab paperweights, T-shirts with laser-etched fault lines, serves as a Trojan horse, smuggling geological awareness into everyday life. The most telling detail, while pop culture obsesses over who made the slab and how, the real fascination lies in why it still matters. In an age of short attention spans and disposable trends, this 500-ton relic commands focus. Its carvings whisper across millennia, not just to showcase ancient genius, but to remind us that some truths unfold too slowly for one lifetime to grasp. The slab's greatest cultural impact might be this: in a world addicted to instant answers, it teaches the value of patient questioning, one tectonic shift at a time. The jungle surrounding the slab pulses with new activity as teams of archaeologists, geologists, and local guides push deeper into the undergrowth, armed with tools that would seem like magic to the monolith's creators. Ground-penetrating radar sweeps reveal more than just soil and roots hidden beneath the earth, are geometric anomalies suggesting man-made chambers, their walls aligned with the slab's orientation as if part of a grander design. These aren't random cavities, their precise placement hints at a purpose, perhaps storage for sacred texts, tools, or even companion stones that could decode the slab's symbols. One archaeologist describes the scans as seeing shadows of a blueprint, where every echo and reflection teases a truth just out of reach. Recent excavations have turned up artifacts that complicate the story further. Fragments of pottery near the site bear faint markings reminiscent of the slab's carvings, but simplified, as if they were practice sketches or teaching aids. Even more intriguing are the handful of stone tablets found half buried in the vicinity, their surfaces etched with symbols that mirror the slab's mathematical sequences but with annotations. Some researchers speculate these could be keys, instructions left behind to interpret the larger work. The discovery reignites debates about the slab's purpose. Was it the centerpiece of an ancient academy where initiates studied Earth's movements, a communal project with contributions carved across generations? Or something more urgent, like a survival manual for a civilization bracing for catastrophe? Technology is bridging gaps that fieldwork alone can't span. Drones equipped with LiDAR pierce the dense canopy, mapping the terrain in 3 dimensions and revealing subtle earthworks that may form a vast, interconnected complex. These aren't the haphazard remnants of a settlement, but deliberate features: raised platforms aligned with solstice sunrises, channels that could have directed water or crowds, even what might be the foundations of observation towers. The emerging picture isn't of a lone monument, but a carefully orchestrated landscape where every element served a function in understanding, or perhaps influencing, the forces that shape the planet. Local knowledge is proving just as vital as high-tech tools. Indigenous elders from nearby communities share oral histories that speak of the stone that remembers, passed down through generations. One tale describes a great gathering where people from distant lands brought pieces of the earth to add to the slab's wisdom. Another mentions star maps drawn in rock, suggesting the carvings might integrate celestial and terrestrial movements. These stories, long dismissed as folklore, now guide researchers to areas where ground scans show potential tunnels or artifacts, proving that science and tradition don't have to be at odds. The most tantalizing clue emerged last season: a buried stone sphere, perfectly smooth, found precisely where radar indicated a chamber's entrance might lie. Its surface is unmarked except for a single groove that aligns with the slab's primary fault line carving. Experimental archaeologists are testing whether it could have been a tool rolled along the slab's grooves to calculate distances or pressures. Others think it might be symbolic, a representation of Earth's core, perhaps, or a cosmic orb linking land and sky. Whatever its purpose, it's a tangible thread connecting the slab to the hidden spaces beneath it, whispering that the answers don't lie on the surface but deeper. With each dig and scan, the site's complexity grows. Soil analysis reveals layers of ash and sediment that suggest the area was meticulously maintained, then abruptly abandoned. Charred plant remains hint at controlled burns, possibly to clear sightlines for astronomical observations or to purify the space ritually. Even the slab's base shows signs of having been adjusted over time, as if its custodians fine-tuned its position to match some shifting benchmark. The more we uncover, the clearer it becomes that this wasn't just a place of study. It was a living laboratory, a sacred workshop where Earth's secrets were not just recorded but revered. The biggest question now isn't just what the slab means, it's how much more remains hidden. Radar suggests the underground network could sprawl for acres, with chambers stacked like pages in a book. Some researchers whisper about the possibility of finding a companion slab, a twin monument that might complete the message. Others hunt for tools or records that could explain the carving techniques or even the creator's fate. Every shard of pottery, every aligned stone, every echo from the earth pulls us closer to a truth that could redefine not just history, but humanity's place within it. The slab's creators went to extraordinary lengths to ensure their knowledge endured. Now it's our turn to listen. The slab doesn't just rewrite history, it holds up a mirror to modern science, revealing blind spots we never knew we had. For centuries, the narrative of human progress has been a straight line, primitive to advanced, simple to complex, but this 500-ton enigma shatters that illusion. Its creators didn't have satellites or supercomputers, yet they grasped continental drift with a clarity that took us until the 20th century to rediscover. That's not just impressive, it's humbling. It forces us to ask, what other insights have we dismissed as impossible for their time? Indigenous cultures today track animal migrations across generations to predict ecological shifts. Polynesian navigators read ocean swells like road maps. These aren't lucky guesses, they're data systems honed over millennia. The slab's lesson is stark. Knowledge doesn't always wear a lab coat. Sometimes it's carved in stone by hands we've underestimated. What makes the slab truly revolutionary isn't just its existence, but how it bridges disciplines that rarely speak to one another. Archaeologists study artifacts, geologists analyze rock formations, historians decode texts, yet here, all three collide in a single object. The slab's carvings demanded collaboration. Someone had to recognize the coastline of Africa in those grooves, then cross-reference it with tectonic models, then trace those findings to oral traditions that might hold missing clues. This interdisciplinary alchemy is where breakthroughs happen. Modern science often silos expertise, but the slab whispers a different approach: weave knowledge together. When marine archaeologists found a medieval shipwreck using clues from Viking poetry, or when astronomers pinpointed a supernova in ancient Chinese star charts, they followed the same thread. The slab isn't just an artifact, it's a manifesto for connected thinking. Perhaps its most subversive gift is the way it challenges us to stay open to ideas that seem, at first glance, outrageous. When Alfred Wegener proposed continental drift in 1912, he was ridiculed, his theory dismissed as fantasy until plate tectonics proved him right decades later. The slab's reception followed a similar arc, first mocked, then debated, then undeniable. How many other truths languish in that middle ground, labeled too wild to pursue? Science thrives on skepticism, but stagnation lurks when skepticism becomes dogma. The researchers who took the slab seriously, who risked reputations to study it, didn't just advance archaeology. They proved that progress often wears the disguise of heresy. At its core, the slab is a monument to curiosity. Its creators didn't carve their knowledge to boast. They did it because they had to, because understanding the Earth's rhythms was a matter of survival, maybe even reverence. That same urgency drives modern science, from climate researchers racing to decode ancient ice cores to epidemiologists scouring medieval plague records for patterns. The tools change, but the quest remains. Look deeper, ask questions, leave markers for those who follow. The slab's greatest irony: in trying to preserve their own wisdom, its creators gave us something far more valuable, proof that human ingenuity is older, stranger, and more resilient than we ever imagined. Their message wasn't just about shifting continents. It was about the tectonic power of an idea, waiting patiently for the world to catch up. Preserving the slab is a race against time, where every gust of wind and drop of rain chips away at its ancient secrets. The jungle's humidity, while nurturing the vibrant ecosystem around it, accelerates erosion, softening the stone's surface and blurring carvings that have survived for millennia. Even the gentlest touch of a researcher's glove can dislodge fragile particles, leaving conservationists walking a tightrope between study and preservation. Temporary shelters now arch over the monolith, their translucent canopies designed to deflect rainfall while allowing natural light to illuminate the carvings, a compromise between protection and visibility. But these measures are just the first line of defense. The real challenge lies deeper in the stone itself. Microscopic cracks invisible to the naked eye spiderweb through the slab, threatening to fracture its intricate maps under the relentless stress of temperature swings and seismic tremors. Chemical treatments offer another layer of defense, though not without controversy. Silicate-based consolidants injected into the stone's pores can strengthen its internal structure, bonding fractured layers like an invisible glue. Yet purists argue that even these subtle interventions alter the slab's authenticity, leaving behind residues future technologies might struggle to analyze. A heated debate simmers between those advocating for stabilization at any cost and those insisting the slab should weather naturally, its decay seen as part of its story. The middle ground, non-invasive monitoring lasers that map surface changes down to the micron, or moisture sensors embedded discreetly in the surrounding soil to predict erosion risks before they escalate. The stakes couldn't be higher. Each fading line on the slab isn't just a loss of history, it's a potential clue to understanding planetary cycles that could inform modern climate models or earthquake prediction. Recent scans revealed previously unnoticed symbols near the slab's base, their meaning still unclear, proof that even after decades of study, the stone still guards untold insights. Conservation teams now work in shifts, documenting every centimeter with multispectral imaging, capturing data in wavelengths beyond visible light to unveil worn-away details. These digital twins, stored in climate-controlled servers across 3 continents, ensure that even if the physical slab succumbs to time, its knowledge will endure. But preservation isn't just a technical challenge, it's a cultural one. Local communities who have lived in the slab's shadow for generations resist what they see as a freezing of something meant to evolve. Their oral traditions speak of the stone as a living entity. It's weathering a natural dialogue between earth and sky. Some propose an unconventional solution: controlled exposure. By allowing select areas to erode at a monitored pace, researchers might uncover subsurface layers or earlier carvings hidden beneath, like peeling back the pages of a geological manuscript. It's a gamble, balancing loss against potential discovery. The clock ticks louder with every passing monsoon season. A recent storm flooded the excavation site, submerging the slab's base for days and leaving mineral deposits that could accelerate decay. In response, engineers are piloting a radical solution, a subterranean drainage system inspired by ancient Roman aqueducts, designed to redirect groundwater without disturbing the artifact. Meanwhile, universities from Tokyo to Berlin host hackathons, crowdsourcing preservation ideas from materials scientists, AI specialists, even artists who work with stone. The best proposals blend innovation with humility, acknowledging that some ancient techniques like the slab's own mortar-free foundation, which has flexed with tectonic shifts for centuries, might still outsmart modern engineering. What emerges is a poignant truth. Preserving the slab isn't just about saving the past. It's about honoring a legacy of observation, patience, and interconnected knowledge that feels increasingly rare in our fast-paced world. The creators of this monument thought in epochs, not headlines. Their work challenges us to match that long vision, to protect not just the stone, but the slow, profound wisdom it represents. Every decision made today echoes across futures we'll never see, just as the slab's carvings speak to a past we're only beginning to hear. The slab's existence has sent shockwaves through the world of alternative archaeology, becoming a rallying point for researchers who argue that mainstream science has overlooked crucial chapters of human history. Unlike vague legends or speculative artifacts, this 500-ton monolith presents something undeniable, a physical, measurable anomaly that refuses to fit neatly into traditional timelines. Figures like Graham Hancock and Randall Carlson have pointed to the slab as evidence of a lost civilization with advanced geophysical knowledge, while more cautious voices like archaeologist Dr. Sarah Koenig urge a middle ground. It's not about rewriting history overnight, but about asking better questions. What makes the slab so disruptive isn't just its age or precision, but the way it exposes the limits of our academic frameworks. For centuries, the study of ancient cultures has been boxed into rigid categories: hunter-gatherers here, agricultural societies there, as if human innovation moved in a straight line. The slab shatters that simplicity, forcing even skeptics to confront the possibility that knowledge could rise, fall, and rise again in cycles we're only beginning to trace. Within this debate, the slab has also illuminated the tension between institutional caution and public fascination. Universities might dismiss theories of prehistoric seafaring cultures or sophisticated earth sciences as pseudo-history, but the public isn't so quick to look away. Documentaries and podcasts exploring the slab's mysteries regularly draw millions of views, not because audiences crave conspiracy, but because they sense a truth deeper than textbooks allow. This isn't blind rejection of academia, it's a demand for transparency. When geologist Dr. Mark Luo admitted, "We've had to revisit our models entirely because of the slab's fault line predictions," it validated what alternative researchers had argued for years, that skepticism should go both ways. If mainstream science can question outliers, outliers can question mainstream science. That push and pull isn't a weakness, it's how understanding grows. Yet the slab's influence isn't just about challenging old ideas, it's about revealing how much we still don't know. Take the recent work of Dr. Anika Patel, who compared the slab's symbols to petroglyphs in India's Bhimbetka caves. Both sites feature identical spiral motifs near depictions of seismic events, suggesting a shared symbolic language for geological phenomena. This isn't proof of a single global civilization, as some might leap to claim, but evidence of interconnected knowledge networks that spanned continents long before we thought possible. The slab's real gift is its ability to blur boundaries between disciplines, between eras, even between so-called fringe and establishment research. When a team of astronomers found that the slab's peripheral markings align with solar minimums linked to earthquake clusters, it wasn't alternative archaeology or mainstream science making the discovery. It was both working in tandem. The danger, of course, lies in the extremes. For every rigorous researcher using the slab to ask bold but grounded questions, there are those who graft wild theories onto its surface: ancient aliens, Atlantean supercomputers, apocalyptic prophecies. These narratives might entertain, but they risk drowning out the slab's subtler revelations. As historian Dr. Elias Nader puts it, the truth is radical enough without embellishment. What's emerging instead is a new paradigm, one where the slab acts as a bridge. Young archaeologists, less burdened by the battles of previous generations, are mining its carvings for insights into how ancient cultures might have documented slow-moving disasters, rising seas, shifting lands over generations. Climate scientists, meanwhile, study the slab's long-term forecasts as a mirror to our own era's need for foresight. Ultimately, the slab's greatest impact might be cultural. It's become a symbol of intellectual humility, a reminder that history isn't a locked vault but an ongoing excavation. Every time a new laser scan reveals another layer of carvings, or a linguist deciphers a previously overlooked symbol, the conversation evolves. The slab doesn't just challenge what we know, it challenges how we know it, and in that space between question and answer, between the fringe and the accepted, lies the thrill of discovery that drives both scientists and storytellers forward. Whether it's a graduate student cross-referencing erosion patterns or a YouTuber animating the slab's predicted continental shifts, everyone's asking the same thing: if we've been wrong about this, what else might we have missed? Classrooms around the world have transformed the slab from an archaeological curiosity into a living textbook, where students don't just memorize dates, they grapple with the same mysteries that stump experts. At Stanford's Earth Sciences program, undergraduates overlay the slab's carvings with tectonic models using augmented reality headsets, watching continents creep apart in real time. Meanwhile, middle schoolers in Norway recreate the slab symbols with 3D printers, testing whether simple tools could achieve such precision. This isn't just about studying history, it's about reliving the scientific process with all its frustrations and breakthroughs. One high school teacher in Chile even turned the slab into a semester-long detective game. Teams analyze erosion patterns on replica fragments to estimate its age, then defend their findings in mock academic debates. The lesson: evidence can be slippery and truth often hides in the gaps between theories. Universities are taking it further, using the slab to bridge disciplines that rarely interact. MIT's Ancient Engineers course pairs archaeology students with robotics majors to reverse engineer possible carving techniques, from sound-assisted tools to forgotten metallurgy. At Oxford, linguistics classes dissect the slab symbols alongside indigenous memory systems like Peruvian quipu knots, exploring how non-written cultures encoded complex data. These experiments reveal something startling: the slab's creators may have been less primitive and more like interdisciplinary scientists, blending observation, mathematics, and art into a single language. The real magic happens when students start asking questions textbooks can't answer. A group in Japan noticed that the slab's fault line markings align with traditional folktales about earth dragons, suggesting ancient disaster warnings survived as mythology. Others compared its spiral motifs to neuron structures, sparking debates about whether the carvers intentionally mirrored patterns found in nature. These aren't digressions, they're exercises in thinking like the slab's creators, connecting dots across time and culture. Even failures teach. When a Berlin class attempted to move a 1-ton replica using only Neolithic methods, their month-long struggle gave them visceral respect for the original builder's ingenuity. Beyond academia, the slab's educational reach keeps expanding. Citizen science projects invite the public to crowdsource symbol translations online, while museums from Cairo to Toronto host Slab hackathons, where coders and historians collaborate on digital reconstructions. The most poignant impact might be in the slab's homeland, where local schools blend Western geology with ancestral stories about the talking stone. Kids there don't just study the slab, they see themselves as its inheritors, tasked with adding new layers to its unfinished conversation. That's the ultimate lesson. Knowledge isn't static, and the past still has things to teach us if we're willing to listen closely enough. The slab's uncanny accuracy raises a tantalizing possibility. Could its creators' methods be reverse-engineered to forecast the Earth's next great shifts? Modern science relies on satellite data and supercomputers to model tectonic movements, yet the slab's ancient carvings suggest alternative pathways to prediction. Researchers at the University of Reykjavik recently made a startling discovery. Certain symbols clustered near the slab's edges align with historical earthquake swarms, hinting that its creators might have tracked seismic patterns invisible without modern instruments. Even more intriguing, the depth and curvature of these markings correspond to stress buildup along fault lines, as if the carvers understood the physics of friction and pressure millennia before the concept entered textbooks. This isn't just archaeology, it's a potential blueprint for a new kind of geological forecasting. Consider how indigenous knowledge already fills gaps in modern science. The San people of southern Africa interpret subtle shifts in animal behavior to predict droughts, while coastal communities in Indonesia read wave patterns for tsunami warnings. The slab's creators likely employed similar observational genius, but on a planetary scale, by cross-referencing the slab's symbols with oral traditions from cultures living near tectonic boundaries. Scientists have identified recurring motifs, spirals that might represent cyclical quakes, or zigzags echoing the stick-slip motion of grinding plates. These aren't mere decorations, they could be data visualizations, a prehistoric code for Earth's restless movements. The real test lies in applying these ancient insights to contemporary threats. A team at Caltech is developing an algorithm that combines the slab's symbolic patterns with real-time seismic data, searching for predictive correlations. Early results are provocative. Areas marked by dense clusters of dots on the slab have experienced significantly more quakes over the past century than neighboring regions. Even more compelling, the slab's depiction of the Pacific Ring of Fire includes subtle indentations where major eruptions occurred centuries after its creation. If these markers aren't coincidental, they might reveal hidden stress points where future disasters could brew, knowledge that could save countless lives. Yet the slab's true power may lie in its long-view perspective. Modern forecasting often focuses on imminent threats, the next big quake, the next volcanic blast. But the slab's creators thought in epochs, tracking changes too gradual for any single generation to notice. Their carvings show continents drifting at rates matching today's GPS measurements, proving they grasped the concept of cumulative motion. This slow motion lens could revolutionize how we prepare for planetary changes. Coastal engineers in the Netherlands are already studying the slab's shoreline predictions to anticipate land subsidence over the next 500 years, while climatologists examine its symbols for clues about ice sheet collapse timelines. The challenge, of course, is deciphering intent. Were the slab's markings meant as warnings, teaching tools, or sacred records? A controversial theory suggests the answer lies in the stone's material itself. Geochemical analysis reveals the slab emits faint electromagnetic pulses when subjected to pressure, a phenomenon called piezoelectricity, common in certain quartz-rich rocks. Could the creators have used the slab as a kind of geological sensor, feeling its vibrations to detect distant tectonic strain? Indigenous stories from the region speak of singing stones that foretold disasters, while modern experiments show similar rocks emit measurable signals before quakes. If verified, this would mean the slab wasn't just a map, it was an instrument. As climate change accelerates Earth's transformations, rising seas, buckling crusts, destabilizing permafrost, the slab's holistic approach feels increasingly urgent. Its creators didn't isolate geology from astronomy or ecology. Their carvings weave these systems together. A single spiral might track both a fault line and a celestial cycle, suggesting they saw planetary forces as interconnected. NASA Earth Science Division has taken note, funding projects that merge the slab's symbolic logic with satellite observations, searching for overlooked relationships between solar activity and seismic events. The ultimate irony, the very continental drift the slab predicted now threatens its survival. Scans show the monolith straddles a growing rift zone, its base slowly tilting as the land beneath it stretches thin. Conservationists debate whether to intervene or let nature take its course, a poetic echo of the slab's own themes. Perhaps its final lesson is this: knowledge isn't just about foreseeing change, but learning when to resist it and when to adapt. As we face our own era of upheaval, the slab's silent warnings resonate louder than ever, reminding us that resilience isn't just technology, it's memory. The slab has become more than just an archaeological wonder. It's now a global laboratory, drawing researchers from every continent into an unprecedented collaboration. Geologists from Iceland's volcanic fields work alongside hydrologists from the Amazon, while linguists fluent in dead languages compare notes with astrophysicists mapping celestial cycles. This isn't just teamwork, it's a meeting of minds across disciplines and cultures, all united by a single question: how did an ancient civilization see what took us millennia to rediscover? The project's headquarters, a repurposed research station near the slab, buzzes with a dozen languages, its walls papered with overlapping maps, some printed from satellite data, others painstakingly copied from the stone's surface. Here, a Japanese seismologist might debate fault line symbols with a Navajo elder who recognizes similar patterns in ancestral stories, while a Brazilian botanist points out how the slab's carved vegetation matches extinct flora only known from fossilized pollen. What makes this collaboration so revolutionary isn't just the diversity of expertise, it's the willingness to question long-held assumptions. When German engineers recreated the slab's transport using Neolithic techniques, their failures exposed gaps in mainstream archaeology's understanding of ancient labor. Meanwhile, Tanzanian researchers noticed that the stone's weathering patterns matched those on local megaliths, suggesting a shared preservation technology lost to time. Each breakthrough comes from these intersections, where Western science and indigenous knowledge aren't at odds but complementary. A doctoral student from Nairobi recently cracked a symbol sequence by cross-referencing it with Maasai cattle branding marks, proving that some codes endure in living traditions. The pace of discovery has accelerated exponentially thanks to shared digital platforms. High-resolution scans of the slab are available to accredited researchers worldwide, allowing a grad student in Oslo to spot a faint constellation pattern that veteran Egyptologists linked to the helical rising of Sirius. Open-source algorithms parse the carvings for mathematical sequences, flagging potential correlations with everything from ocean current shifts to magnetic pole reversals. This democratization of research has unearthed surprises like the realization that certain symbols appear in Inuit bone carvings from the Arctic, hinting at a knowledge network far more expansive than imagined. Perhaps the most poignant aspect of this global effort is how it mirrors the slab's own message. Just as its carvings depict a planet without borders, continents adrift, but connected by invisible forces, the scientists studying it have formed their own interconnected community. When a monsoon delayed fieldwork, Indonesian team members shared drone footage of local megaliths that reshaped the group's understanding of ancient surveying techniques. During a funding crisis, crowdfunding campaigns from 37 countries kept the lights on. Even rival institutions have set aside competition, with MIT and Cambridge pooling resources to build a climate-controlled replica for hands-on study. The collaboration's greatest lesson might be about humility. Faced with the slab's precision, no single discipline can claim supremacy. Geophysicists defer to oral historians when symbols resemble creation myths. Archaeologists consult material scientists about stone-cutting techniques that defy modern replication. This isn't just about solving a puzzle, it's about redefining how knowledge is built. The slab's creators left no written manifesto, but their work whispers a truth we're finally hearing. Understanding Earth requires every voice, every perspective, and a willingness to listen across the chasms of time and tradition. As the project enters its next phase, teams are preparing to share findings through open access journals and community workshops, ensuring the slab's secrets belong to everyone. Plans are underway for a virtual reality archive where anyone, anywhere, can explore the carvings alongside annotations from experts in 50 languages. The goal isn't just academic, it's a testament to what happens when borders dissolve and curiosity becomes the common language. In a world often fractured by divisions, the slab has become an unexpected unifier, proving that some truths are too vast for any one culture to hold alone. The 500-ton stone slab stands as a silent witness to a truth we're only beginning to comprehend, that the past might hold keys to understanding our planet in ways modern science has yet to imagine. This isn't just an artifact gathering dust in a museum. It's a living puzzle, its carvings whispering across millennia with unnerving precision. The implications ripple far beyond archaeology. If an ancient civilization could map continental drift thousands of years before Alfred Wegener coined the term, what other fragments of forgotten wisdom might be scattered across the globe, hidden in plain sight? Consider the parallels to today's most pressing challenges. As modern scientists grapple with climate change and tectonic threats, the slab's creators offer an unexpected model, thinking in scales of centuries, not election cycles. Their approach wasn't just about observing the Earth, it was about listening to it, tracking patterns too gradual for any one lifetime to grasp. Indigenous cultures from the Arctic to the Amazon still practice this long-view science, reading animal migrations or tree ring patterns as early warning systems. The slab bridges these worlds, proving that ancient knowledge isn't obsolete, it's a reservoir of insight we've barely tapped. Yet the most humbling lesson lies in the slab's very existence. In an age where data lives in fragile clouds and hard drives, its creators chose stone, a medium meant to outlast empires. They understood that some truths are too vital to entrust to parchment or oral tradition alone. This deliberate durability raises a haunting question. What did they know that made this message so urgent? Were they documenting a cycle, a planetary rhythm we've yet to recognize, or leaving instructions for survival after some anticipated catastrophe? The symbols we've deciphered might be just the preface to a much deeper warning. The slab also forces us to confront the gaps in our historical narrative. For centuries, academia dismissed non-Western scientific traditions as myth or superstition, only to rediscover their accuracy through painstaking modern research. The Aboriginal songlines that map Australia's coastline with GPS-like precision, the Inuit oral histories describing extinct megafauna, these aren't legends. Their data, preserved through generations with meticulous care, the slab shatters the myth of linear progress, revealing instead a tapestry of brilliance, loss, and rediscovery. What makes this discovery so electrifying isn't just what we've learned, it's how much remains hidden. Every new scan reveals previously unnoticed markings, like the faint grid near the slab's base that some researchers believe could be a primitive coordinate system. Others speculate that the stone's magnetic anomalies might encode information in ways we've yet to decipher. The more we study it, the clearer it becomes. This isn't a message that was meant to be solved in a decade or even a century. It's a conversation meant to unfold as our own understanding grows, as the jungle reclaims the site each rainy season, and new technologies peel back layers of time. One truth emerges with crystalline clarity: history isn't a closed book. It's a living story, and the slab's final chapter hasn't been written. Perhaps its greatest gift is the reminder that curiosity has no expiration date, and that the next great revelation might lie buried beneath our feet, waiting for the right moment and the right minds to bring it to light. The stone has spoken across ages. Now it's our turn to listen.